Hello, hello. Welcome to the first Bevy Game Development Meetup. I'm so happy that this is coming together. One of my favorite programming languages, one of my favorite game engines, and this is the first meetup all around focused on Bevy. So, hello, I'm Stefan. I'm not going to keep much of your time because we have 6 amazing speakers. So let's quickly check out the agenda for today. We have 6 amazing speakers, 15-minute lightning talks each. I have roughly reserved 5 minutes of Q&A, plus minus, depending on how much more time people are using. So let's see how that gets out. Check the QR code in the stream for the Q&A platform. You can just, without any login, go there, ask your questions. I'm going to monitor that and try to, and vote on the questions of everyone so we can focus on the most important ones that are the most popular, let's say. So as you can see, this is all live streamed. It will be recorded though, so if you cannot stay for the whole 2 hours, don't worry, there will be a recording. I'm not sure how fast I will be, but I will upload them all after the meetup is concluded. So obviously, Rust community means little short code of conduct. Be kind, be respectful, but also be curious. We all want to learn more about Bevy here today. And if you observe anything suspicious, let me know, reach out to us, and we look into it. Who am I? I'm Stefan. I am working with Rust since 2017. Overall, 17 years in the games industry. I'm the creator of Git UI, all written in Rust, and LiveAsk, the live Q&A platform that you're hopefully using now. And I just recently founded my new company, Rust Unit, sponsoring this meetup. So if you want to reach out to me, go on rustunit.com. So here's the Q&A code one more time, very big. And now I'm going to give the stage to Alice with our first talk.
Hi there, I'm Alice.
Hey, Alice.
If you haven't, I'm sure most of you already know me. I'm one of the maintainers of Bevy, and there are my slides. So I'm going to jump right into the talk because I'm here to answer a question that you have today. It's what the fuck is reflection? So you may have heard us talking about reflection. Oh yeah, we have Bevy Reflect and we have weird macro heavy code and all of that, but it can be an intimidating topic. So in order to kind of get an understanding of where my audience is at, I did a informal poll of one professional Rust developer who happens to be my girlfriend. And this poll revealed that professional Rust developers think that reflection has something to do with type information. It's definitely complicated. It's probably important for Bevy's internals somehow. They don't really have any clue how it works. They're not sure why it's useful, but they know for a fact that it's probably cursed. So let's break it down into really simple terms. Let's try to understand what this is and why it's useful in a simple way. So when I was trying to write this slide and doing my research, I was like, I should make a succinct summary of what reflection is. But turns out David Drysdale from with his effective Rust book thing, it's really great. You should read it. Has a great quote, which is, reflection is the ability for a program to reason about itself at runtime. And in Rust, we usually mean that the program is reasoning about its type information at runtime. And we can use this to build powerful abstractions that work around the language limitations, or they're used to interface with external tools, things like serialization, where you have saved games and networking. In terms of abstractions, we have things like dynamic value editing. So if you've ever used Bevy Inspector GUI and twiddled the values and watched them dynamically change, that's all done through inspection, through reflection. So then you don't have to write getters and setters for everything. And finally, the third use case we're going to talk about today is Bevy's new runtime defined component and resource types, which is coming in 0.13. So we're talking about reasoning about a program itself at runtime. So what information can you actually access at runtime in Rust with today's code? So within Rust itself, we have some very basic but very useful primitives for reflection. So the most important one is type ID. Type ID is just like an opaque identifier, which is kind of like how entity works, where every single type will have its own U64 or something. And that number will tell you what the type is. And critically, things. This is completely opaque. There's no rhyme or reason to it, and generic types, things like a vector of f64 versus a vector of u8, these will each get their own type ID and they won't have any relation to each other. So very useful as a stable identifier, but doesn't give us anything else. The next thing that we get is this trait called any, and the any trait is in some ways kind of the ultimate trait. Everything can be coerced to an any. And what you can do with it with an any trait object is you can downcast it into a concrete type. You say, okay, I want my type out, and then you say, okay, please downcast it. I promise you that this box is actually a my type, and then you unwrap it and you hope that you didn't screw up any of your accounting. But really quite cool and foundational. There's also type name, which gives you the name of the type, but this is fundamentally unstable and they make no guarantees and it's for debug information only, and you definitely shouldn't do anything fancy with it. And then two other ones that I'm gonna argue are reflection, which is the size of and offset of method and macro in this case, and these will tell you the layout in memory of your types. And Bevy actually makes use of these when trying to store its own dense storage of our component and resource types. So we also have, though, we're not limited to the tools that just Rust gives us, right? We can write our own, reflection libraries. And in particular, we have Bevy Reflect, which is a runtime reflection library. So it'll let us at runtime, so while the program is running, get information about the types of our objects. So Bevy Reflect fundamentally operates on types, and on instances of those types, and it doesn't work. It doesn't actually. You can't reflect traits currently because there's no way to store the data or anything. But you get information about, like, is this a struct? Is this a tuple? Is this an enum? It's kind of the most basic information. Then you can get out the field names and the types of all of those fields for all of the fields of your structs. You can kind of abstract over these over the different types of data structures you might have. You might want a list. You might want a map. You may want to iterate over a list. And you can do this in a generic way. I'm sure the functional programming people are like, oh, I know that. It's a hack, but yeah, it's good. And it'll also give you information about the path of the type. So where is this at? It's like Bevy ECS system query or whatever. Like, that's the type path. You can also reflect documentation, which is a very cool trick that I was very surprised to see worked when we got the PR for it, but I'm pleased it exists. And finally, you can, if you make a shadow trait and the trait is type safe, object safe, and you manually register the trait, you can even get information about which traits are implemented for that type. So if you're a beginner to Rust or beginner to programming more broadly, you'd be like, okay, yeah, sure, this makes sense. It's kind of hand wavy, but yeah, okay, sure, we could do this. But if you're a Rust expert, if you've been in the community for a long time, you'll have some questions, because Rust doesn't have reflection. Like, that's the line, and it's kind of basically true. Like, we don't have compile time reflection. We don't have a first party reflection capabilities. It's not great, but we do what we can. So traditionally, reflection libraries, reflection tools in other languages are implemented by the language themselves. So things like Java and Scala and so on. What they'll do is they'll either have the type information passed in at runtime, or you'll be able to hook into the compiler API. And neither of those things are particularly possible in Rust. So the compiler API in Rust is churning and private and wildly unstable and not very useful. There's talks of this upstream in the Rust project to change that via a process called libraryification, for when you really like to get turned into a library, I guess. But that doesn't exist yet. And finally, the type information is erased at runtime. Like, all we get with our types is that debug type name and the type ID, and everything else is totally stripped out for speed and memory usage and all of that. So we don't inherently get access to this. But we can work around this. What we can do is we can make our own reflection framework by modeling Rust type system using Rust type system. And in order to populate that information, we write our own compiler. We use derived macros, and we look at the actual source code of those structs that you're defining, and you say, okay, what are the fields? What are the field names? What do they store? And you break it down recursively until you have until you back down to the primitives that we've manually said, okay, this is a value that we can reflect, and we know how to represent this. And then you have these complex nested structures that recurse down until you have a full way to capture any struct in Rust, hopefully. And then we take all this information that we generate through the derive macro, and we're going to register it into a type registry, which is in Bevy, generally stored on the world in one form or another. And then you go and you say, okay, I want information about this type. Tell me metadata about this type. And so in this way, we can go and actually access this type information at runtime, basically by writing our own compiler and bypassing everything that Rust wants us to do. But that's okay, because macros are powerful. So let's get into this a little bit more tangibly. So this is kind of a mid-level struct that we find in Bevy Reflect. This is, I thought this one was very interesting and very approachable. And so we start off at the top above this at the reflect trait, which is kind of the central trait that says, okay, everything that's reflectable can be represented as a dyn reflect trait object. And then from that, we can get things like its type info. And the type info is information about the type, shockingly. And this information, this type info, is itself an enum, and one of its variants is enum, which stores a struct called enum info. And that's what you see over there on the right-hand side of the screen. Although it mirrored. Anyways, so in this, what do we see? Okay, so we see the type path. We have something called the type path table, but this fundamentally lets you look up what the type path of that type is. Then you have a type ID, which is, again, that stable identifier. You have the variants. So we have a box slice variant info. So basically an iterator over the information of the variants. And this will give you the names of the types. They'll give you the names of the variants. They'll give you the type of them, and then you can have nested types within there, and you'll recurse down. And then you'll have a way to quickly look up the variants by their name. That's what the variant indices is for. And then the other thing that you'll notice there is we have a feature flagged field called docs, which will just give you an option to a string. So then if you have the docs and the docs were properly generated and the docs exist, you can just pull them up you can just pull them up at runtime and say, hey, what's the docs for this type? And I'm very excited to use that for the editor. So you kind of get some sense of how this works and everything, but what is it actually good for? So let's go into one of the most common and straightforward uses of reflection, which is serialization and implicitly deserialization. So serialization is the process of converting data into a type that can easily be stored or transmitted. So things like save games, where you're trying to store this complex data onto disk, or things like networking, where you're trying to produce these packages in efficient form and then send them out and then deserialize them back into a game object that you can work with. And in order to serialize things, we need to understand what its shape is, what its field is, and especially to deserialize things. And so you'll need to know the fields, the field names, the type of each primitive value, and some sort of representation that matches with like what JSON or RON wants, which is like, is this a list like? Is this map like? Is this value like? And so Bevy Reflect by itself can be used entirely as a standalone serialization library. No Serday needed. And again, all of this information is generated through that derived macro of reflect, which will go through and parse your fields and so on. So let's talk about a different application, something a little bit more complicated, but very, very, very useful for games. So this sort of tool, Bevy Inspector GUI, if you haven't used it, you should. It's great. Put it in all your projects. You pop it up, and you say, okay, tell me the list of all of the entities that are in this game in my scene right now, and what are the components. And then you can go and you can actually live edit their different values. And this sort of ad hoc dynamic typing and like value editing and stuff is really characteristic of reflection and of dynamic typing. And you could do it like you could do it without reflection. It would just be an infinite amount of boilerplate that you need to constantly update every time you add another new thing. But with the way that Bevy Inspector GUI is implemented, and with the reflection, and hopefully how the equivalent tool is first party tool works, is it looks through the reflection, it parses the values, it says, okay, it's going to look like this, and then it says, okay, yeah, that's a float field in there, and this is the name of it, and it can go and automatically generate and populate these menus for you. And so this abstraction is incredibly powerful and a huge time save for game editors. And fundamentally, this is a huge part of why Kurt initially built Bevy Reflect, is because he knew that these tools are essential for game development, and we can't do it's with the existing Rust ecosystem, we couldn't do things like this comfortably. Finally, we'll go into the most advanced, the most galaxy brain application of reflection in Bevy today. So this is something you may have heard people talking about, where they have a different language that they want to interface with Rust, and they want scripting or modding support, and they're like, man, I really just want runtime defined components and resources types, so you can just go and you can just add more, and they'll work just like any other Bevy component, but they're defined at runtime, and they can be defined from outside of Rust. And this is where that's fundamentally what this application is useful for. I mean, it's probably also going to be useful for relations, but relations uses lots of curse magic. So what you can do is, the way it works is that when ECS data, so components or resources, are inserted into the world, they'll be initialized with a component ID. So a component ID is just a unique identifier, a unique opaque identifier. We love unique opaque identifiers in this house. And they'll get a component ID, and which is sometimes a type ID, but if it's a runtime type, it's a runtime defined identifier. Then we're going to go and we're going to store this type information using reflection in the world as a component info. Then within our world, ECS world, because we really like performance, we're going to go and we're going to have a dense, it's called a blob vec, for all of our contiguous arrays of nicely aligned data. And again, we're going to look at the component information to figure out, okay, how big are these types? What are the different pointer offsets into the fields? And then we'll use pointers to actually operate with those. But because we're using these opaque identifiers and we're using pointers anyways, we can just expose this information to the scripting language with unsafe APIs. And you can just say, okay, hey, the scripting language can say, okay, please go and modify the value of this component at and this field of this component of this entity from to, and please set it to this F32. And it can just do that. Like there's no, and it can do that with very, very, very little performance overhead. Or at least certainly a lot less than you expect it to require. So we're still fleshing out this API. We're still going to make it. We still have to stand off the left corners. But coming in Bevy 0.13, I think all of the fundamental pieces are there. We have all of this runtime type information, and critically, we have the ability to construct queries dynamically. So, in conclusion, let's talk about this. So, should you, as random Bevy user, as Bevy library developer, as Bevy engine developer, should you use reflection? So, the first pro for reflection is that it's wildly flexible. You can do anything with it. You can be like, okay, I'm gonna go and I hate this compiler error, or I hate this the fact that traits aren't exposed at runtime, and I really want to query over traits. And you can just say, no, I'm just gonna bypass that by adding more information to the reflected type information, and then just asking for it. The first con, and first most important con, is that it is wildly flexible. It's very easy to galaxy brain yourself and use reflection when you don't need to, and create this like horrible unmaintainable mess. Reflection is definitely a tool of last resort, but you know, when you're at your last resort, it's much better to have something than to just have to give up. And on that note, some of the other cons of reflection are, the biggest one is that it has a runtime performance cost, at least for most applications. Like there's several levels of indirection. You have lots of lookups. You're saying, okay, please look up this type of information and then convert it and then convert it and then convert it. And then you can do the thing that you want it to do. And if you can avoid that, it's faster to just not do all of those intermediate lookups. If you worked with reflection and Bevy, you'll also be aware that there's a fair bit of boilerplate involved. You have to drive reflect on everything. You have to make sure it works. You have to make sure that the orphan rule doesn't bite you, because the orphan rule sucks. And it's like, okay, yeah, you don't own that object. You don't own that type. You don't own that trait. Too bad. You have this cool third-party library that's not designed to work with Bevy, and you want to reflect it. Too bad. And then you have to go and actually register your types in the app or the world. It only works with types that have a static lifetime, because that's a requirement for to get a type ID out of it. And it only works with object-safe traits. So object-safe traits are basically ones where you take self or left self or something in each of your trait methods. So then you have a place to, I believe, store the vtable information. But reflection is really good if you need to abstract over the type system in really complex and abstract ways. Where if you're doing things like making an inspector, if you're making trait queries, if macros, or maybe networking, or like a remote editor communication API. Like, yeah, this is a pretty good tool for that. Like, if you're working at like galaxy brain levels of abstraction already, like this might actually be the tool for you to work with. And it's also, if you're trying to translate Rust data into not Rust or vice versa, like reflection is just the tool you should use. Like just reach for it and poke around at how we do our scene serialization, poke at how people do networking stuff. This is the tool. And then the final con is that, yeah, having reviewed PRs and made contributions to Bevy reflection is definitely probably cursed. The beginners are correct. So yeah, that's my talk. I have a bunch of further reading linked. I'll promote my I'll post my slides with better formatting online, and there's a bunch of interesting resources in terms of both crates and in terms of further more in-depth explanations that are really worth poking at if this topic was interesting to you.
Amazing, Alice. That's a crazy topic, and I can't wait to play more with it in 0.13. So there's a bunch of questions. Let's start with the most high upvoted one. Can reflection ever fail at runtime in any way, or are there any common problem situations to look out for?
Yeah, so reflection. So generally speaking, there is a lot of option types. There's a lot of result types, and you need to be careful that when you haven't screwed up your mapping between the different types. And generally speaking, you're just throwing a hash map of whatever string or identifier you want into a type ID, and then you use the type ID as your primary key. But if you screw that up in any way, and then you're just unwrapping all over the place, like, yeah, you will get panics. You will screw up, or you'll get failures. The other biggest problems that I have with reflection is that it's very, very easy to forget to derive things, or forget to initialize a type thing. And then you're like, why can't my scene serialize? Why isn't this showing up in my trait query? All of that. It's because you forgot to register to the type registry. And we can't fix that easily. We need changes upstream in Rust to, it's called life before main, where you'll go and you'll actually inspect the source code of your whole program, and then go and insert go and be able to do things like register all of the types that implement this thing. And we can't do that. There's a crate called inventory, which can kind of do this, but it doesn't work on Wasm, so we don't use it.
Is there any chance that we might get that into upstream?
This is something that the Rust leadership is sympathetic about and like is open to solutions for this. There's also some sympathy and controversy around compile time reflection, which would help a lot with a lot of these things. But like with all things with upstream Rust, I will believe it when I see it. Organizationally, they get things done. They don't necessarily get the things that they want to get done. So.
Got it. Okay. Another question is, do I understand correctly that compiler information will be exposed at runtime via proc macros then? Is this used internally or only for world serialization and inspection?
So Generally speaking, you can run. You can use component resources and the standard ECS stuff all completely without reflection. We'll use we use things like size of and stuff inside of our internals, but there's no proc macros involved there. So the reflection is only for advanced use cases and for serialization within Rust itself, within Bevy itself.
Gotcha. Okay. And someone was wondering about component ID and if it could be used to register components for each enum variant to be able to query for enums by value.
Yeah, and so that's definitely something we could do. The problem there is that we would need to, so we could absolutely query for enums by value. Like that's totally feasible. We wouldn't be able to use the same syntax that you're used to, where you just say ref option none or whatever. Like this won't work because in order to generate those to generate the world query trait implementations, we need to actually have a concrete type that Rust recognizes in order to implement that trait on. So what we'd have to do is we'd have to probably use this, expose this only through dynamic queries, and then you have to pass in a concrete value, which may actually work. And that would be something I'd be interested in seeing explored. However, in order to get that working properly, you're going to want to have an index which is reliably updated and synchronized and efficient and actually faster than just iterating over the list and so on. So like this is something that we could do, but it's like a 5-part research project if anybody's interested.
Yep, gotcha. Okay, last question. I guess we have to defer the rest for maybe at the end if people have more time to stick around. So how much would a better built-in Rust reflection benefit Bevy? Would it make crates like Surdy obsolete?
Yeah, so this is a complex question. I would definitely defer to people like Mr. GVSG, who is much better at reflection than I am. But my understanding is that the primary benefit that Bevy would see from compile time reflection and built-in reflection from Rust is not having to deal with the orphan rule. Not having to deal with the orphan rule would be really nice, and shorter compile times, because this could be built into the compiler. We could hook into what they're already doing. We could, rather than generating a pile of code for each of them. And yeah, like there's absolutely a world where things like Sode representations are basically automatically generated from every single Rust type, and this would be great for us because we want that information too, both for serialization and for not. And then you could have manual overrides for custom, highly efficient or specialized serialization formats. But like generally speaking, this could be done, assuming you were able to get the compiler internals to cooperate, which is easier said than done, both technically and organizationally.
Yeah, makes sense. Okay, let's stop here and maybe see if we can have a panel discussion at the end to follow up with the rest of the questions. It's a super interesting topic. Alice, great talk, and thanks for coining the term Galaxy Brain, finally.
I'm glad.
So next up, we will see a presentation by Chris Biscardi. Chris, you are on stream.
Cool. Hello.
So let me quickly pull up your slides as well. And I don't think you need more introduction. Everyone knows your face from YouTube if they're just remotely interested in Rust and Bevy. So giving it away to you, Chris.
Hey, chat. See a bunch of people that I've seen before. So today I'm going to talk about how you go from an idea to a series of experiments to a functioning game. And we're going to cover getting started with Bevy from the perspective of doing many small experiments, how you can kind of use those experiments to build up into a larger game, and how Bevy makes this whole process possible. And in some ways, this talk is an appreciation for Bevy's ECS and how that combines with the plugin system to guide the creation of these individual Lego blocks that can combine into a larger game. I would categorize this almost as a through line from like building ECS through to developing plugins. But the more and more I think about it, it seems just like a circle, honestly. If you're already building a Bevy app, you're already working with the ECS and you're already building a plugin, which makes working with abstraction and building larger groupings of game out of Lego blocks a lot easier. So how do you start? Once you've decided to use Bevy, the question is, how do you start? In other words, where do you get your first piece of Bevy code from? And when I started, the first place I looked was the Bevy book. Today, this starts you off with the smallest possible Bevy app. But if you're looking to experiment and do a lot of experiments, this is likely not what you're looking for. It's useful to have a little bit more of a floor to stand on. After all, this basically runs and then exits. So we could add the default plugins, and that gets us a window and a constantly running app. But that's not quite enough either, because we still need a place to run our own functionality. And Bevy, again, has an answer for this in its systems and the ECS in general. A setup system is a likely first addition, if only to add a camera to the screen. And we can keep adding more systems for different functionality and so on. So what we've set up now with a Bevy app, and this is roughly the base of any new Bevy experiment. However, there's still a gap between this code and working on that idea we had when we started out. Starting from this many times requires a lot of duplication. Consider, for example, the January project, which has a different prompt for every day of the month of January. To participate, you have to start a new Bevy app every day for each prompt. And ideally, we'd be able to start a little bit closer to the kind of app that our idea represents. We often want to implement specific kinds of scenes or other functionality, and for that, there are even better starting scenarios. For example, the Bevy examples. In my mind, the Bevy examples are the #1 starting location for an experiment. These examples are well curated and maintained across releases. If you have an idea for a new shader, an in-game UI, or a specific game mechanic, the Bevy examples hold a wealth of great starting states that exercise different features of the engine in different scenarios. When you take one of these examples as your starting point, you kind of get all the things we've already talked about to stand on top of. You get the default plugins. You get a setup function with a camera. You often get an update system and a scene that it operates on, as well as some of the more specialized initialization code. Here you can see some lighting. Here's an extended standard material. And in this example, we have a UI material. You can, to some extent, use this as an officially maintained snippet of useful library functionality, which is actually incredibly helpful when building out new experiments. So once you've found a good starting state, it's time to start extending it with the behavior you want. This is a process that will combine both the creation of new systems as well as the usage of plugins, which is one of the larger points that I want to get across today. When you're writing a normal one-off Bevy app with regular systems, you're also effectively writing a plugin that you can pull out into a separate crate and reuse. Here's an example of one such project that started out life as an Advent of Code solution. The text file on the left is translated into a static rendering of the bricks on the right. It started off life as a standard material extension Bevy example, and then an additional for loop just to render these cubes in place statically. I already had a parser from doing the Advent of Code problem during the month of December, and one really interesting consideration is that the parser constructed the IVEC3 struct from GLAM. Bevy, it turns out, is extremely modular, and the crates used to build up the engine, even if they're not in the main multi-package repo, as a whole, can be used piecemeal, even when you aren't intending to use that code in a Bevy app. So up until this point, the experiment was one giant setup system, but I wanted to be able to move the camera around. And there's a great unpublished crate that I use all the time. Whether I copy the code into my project or drop a quick Git dependency, this slide is effectively a thank you to Griffin for the Bevy basic camera crate, because I find it incredibly useful and I use it all the time. After that, I wanted to make some bigger changes, and this brings me to one of the techniques I find myself using the most when I'm iterating on these small experiments. Cargo has built-in support for an arbitrary number of binaries, as you can see on the right here. So whenever I'm going to create a large new set of functionality or modify things heavily, and I want to keep what I have, I cut a new binary and I keep moving forward. Yes, you can keep history in Git, but I find it much more nice to have my old experiments around so that I can run them and see what they look like compared to what I'm currently working on. So I built a tower, and the next obvious fun thing to do is knock it over, as you can see here. Falling bricks is something we can get from another plugin, Bevy XPBD, which is actually covered in depth today in another talk, so we're mostly going to skim over it. Adding the plugin and using a couple of components on our cube spawns is all we need to see a beautiful set of cubes falling. The tendency of Bevy plugins to operate using the addition and removal of components makes combining different sources of functionality easy to use and easy to remove. And we can continue to play with this different functionality to find something we like. In this case, we lock the rotation, causing all the cubes to fall vertically with no rotation and no horizontal movement. At this point, though, it's getting pretty hard to see the beginning of the physics simulation, so it's back to the Bevy examples we go to pick up a small game menu example from the state example. This in particular is something that I would love to package up. This in particular is something that I would love to package up into a quick use plugin for these little experiments. I often want to delay the experiment from running until I have the right screen size or, a screen recording running. So you can see the menu here in the top right, and then you click it and the game starts running. I can easily see this being one other small plugin and being extremely useful for smaller experiments, as well as growing into bigger games. At this point, I'm feeling like this could be a game and not just a pretty visualization of bricks. So it's time to start experimenting with some mechanics for interacting with the tower. Break out yet another binary. Again, the most obvious mechanic to me was make blocks fall. Perhaps I've just failed a little too much at Jenga growing up. So I wanted to implement clicking a particular block to remove it from the world and let the rest of the blocks fall around it. Bevy mod picking is the choice for this for me today. Again, the way we introduce the plugin that provides this functionality is via components on our entities. It's worth mentioning that as you build out experiments, if you find yourself building functionality that you can connect to components like this in this pattern, which you likely will, it marks a great point for your own potential plugins. And this was a great series of experiments. So I took everything I'd built and the relevant files and put it into a GitHub repo. Then I grabbed some GitHub actions and started making releases. There's some really interesting features coming in Bevy 0.13 that I think would make dropping blocks into the game a lot more fun. So I'm actually pretty excited about continuing to work on this one. But that's not the only time that I use this workflow. So next, let's talk about a similar project that started off with a combination of two examples from the Bevy repo, the standard material extension example and the post-processing example. Why? Because this is for a post-processing pixel effect that takes advantage of Bevy's lighting system. I know that using the standard extension or standard material extension APIs will allow me to take care of inserting my various shader logic in the middle of the light processing code without needing to explicitly write my own lighting. The post-processing is what will enable us to start off with the pixelization, which is effectively just rendering to a small texture and then scaling that up. This is what it looks like, roughly now. And this is what it started out as. Just a cube that has soft edges, and the colors are, if you can tell, changing a little bit too much with the quantization. From here, the most interesting changes happened in the shader WGSL code. We're using the depth and normal pre-pass textures on our camera to draw outlines on the mesh in our shader. As you can see here in the top, or on the top left, on the left, there's this dark outline that's using the depth texture. And on the right, there's this light highlight that's using the normal texture. WGSL is live reloaded when the files change, which is invaluable to doing this work and, visually viewing things as you work on them. The color quantization issue was fixed by quantizing on the LCH representation of the lightness, which produced an effect here that I was pretty happy with. Lots of small changes later, I got to the point where I wanted more scenes, and the easiest way to build more scenes is to have a plugin that encapsulates all of the post-processing and camera work. With a plugin, the big takeaway here is that all we need to do is add this pixelization effect in the scene using the pixelating plugin, and then add the pixelated camera component to the camera we're using. All of the rest of the logic, all of the messy logic that I wrote as I was doing this, without really intending to ship this as a library, is embedded in the plugin code on the left. This plugin itself is basically structured in the same way as the messy experiment code was, like I just said. It looks almost exactly the same as a regular Bevy app because of the way the plugin API works. So we end up with all the post-processing, material providing, setup code reusable across more binaries. Beyond the regular code we'll write in our experiments, one thing I want to call attention to is the inclusion of what I'm roughly calling do this when the component is added. We have a configure pixelated camera system running on update, but only operating on cameras that have just had the pixelated camera component added to them. So when our camera spawns in, this function will operate on that camera, updating it to use the render layers or any other configuration we need it to. This is how we're hiding the necessary configuration of the camera behind this component insertion API, and it's a really powerful pattern that I see used in a lot of different plugins. And with this plugin, we can port the other examples from the Bevy repo easily. This example shows up this example shows off all of the shapes that Bevy provides, and is actually one that we saw earlier in the talk even. But now with our pixelization plugin applied, we get the effect we just built up through a bunch of small experiments. And with that, we can start putting even more into our scenes. Consider driving a little taxi cab around in a pixelated environment using some input. In this case, these spheres are actually representations of light, and that light is falling on this plane around the taxi cab. So we've taken advantage of Bevy's built-in lighting system and not had to written any lighting code of our own, which in my opinion is wonderful. This is a fully 3D game using imported GLTF models, taking advantage of, again, Bevy's built-in lighting system. And we were able to build it up through a series of small experiments before abstracting the core reusable functionality into a plugin and continuing to experiment on top of that. So I hope that I've convinced you that building a lot of small experiments is a viable way to build out isolated functionality, as well as an interesting way to take those systems and package them up to be reused in larger games. The way Bevy's ECS requires systems to declare their dependencies makes building APIs that operate on just the set of entities or cameras they need a structural part of any Bevy application. From the initial batch of code through to building plugin abstractions and combining those abstractions to create larger games, Bevy feels like a cohesive unit with its ecosystem, and makes experimenting to create new functionality a part of day-to-day life and day-to-day Bevy development. And that is it for me.
Chris, thank you so much. And this is a great talk about the way how you approach your projects and experiments. I love that, especially because you also share this in your videos over and over and make it really stand out how accessible Bevy is to get started with these things. So thanks for that awesome presentation. And yeah, thanks for showing what nice things with shaders you can do in Bevy that I could never do. So we have a few questions here. Let's start with, after having created many small projects and experiments, what would you say is the most annoying thing when you set up a new Bevy app or a new experiment?
The most annoying thing, I think, the thing that I covered in the video, which is basically when you need to start a new project, Bevy has this huge benefit of not being too opinionated and being very modular. But if you're doing a lot of different examples of the same kind of project, if you're, say, doing January and you're doing a different compute shader every day or something like that, there can be areas that require a lot of boilerplate. And then I find myself consistently going back to the Bevy examples just to pull out some better starting place. So I actually fixed that using the Bevy examples, but definitely, we've got the material API, which is really nice and really succinct for writing, fragment shaders and vertex shaders, but we don't have the same APIs right now for compute shaders. And, same thing for a bunch of other features inside of Bevy.
Yeah. Still some way to go. And then someone asks, what would be a game that you don't want to build in Bevy?
A game that I don't want to build in Bevy?
Or you would not build?
I probably wouldn't build right now a AAA, like I wouldn't try to go build Call of Duty or, World of Warcraft or something. That's not to say like MMOs are a bad fit or anything like that. But yeah, I don't know. Those are very like 5 to 7 year projects in my mind, or like at least multi-year projects. And Bevy changes a lot. We get a lot of new great things every 3 months. So yeah, that's what I would have to go with, I wouldn't really
Yeah.
use Bevy for a AAA title, or if I was targeting like the Nintendo Switch right now, for example, you can't really do that out of the box.
Yeah, that's true for all consoles, I assume. And do you think Bevy should create some templates to work with Cargo Generate to quick start sample projects?
So the reason that the Bevy examples stay up to date is that they're kind of built into the repo, right? And being somebody who creates a lot of educational material, a lot of videos, keeping templates up to date with the intent of multiple people being able to use them and maybe configuration, I feel like starts to tip the scale a little bit into maybe being unmaintainable. I think that keeping the examples in the repo as they are currently, and whenever people make PRs, kind of fixing the examples that they change, is a really maintainable way to do that. But once you start pulling out that code into other repos or putting it in other locations, it starts to become very hard to synchronize those changes. So I don't know. I don't think that I would suggest building out a bunch of Cargo Generate templates to the Bevy project. I think I would keep it as the examples because they work pretty well. And if you are, used to working with Bevy, it's pretty easy to go in, find what you're looking for, and then apply it to your situation.
Yeah. Okay. Last question in the spirit of time. Maybe you can also hang out later for follow-ups. Because there's still more coming up. But last question: how do you handle the plugins depending on other plugins? What's the best way now or in the future, in your opinion?
Right now, I think that component-based API is really the way that I would suggest doing it if you can. I think if a plugin depends too heavily on another plugin, maybe it's not actually separate plugins. But in the meantime, the way that I would think about sort of APIs between different plugins, which is really kind of what's being asked here, is dealing with these components that are being added and removed and things like that. So when you have a certain type of component being added, maybe your component can work with two different physics libraries or something like that. Yeah, that would be my suggestion. My suggestion would be like make sure your plugin APIs are actually plugins and not just pieces of your code that you happen to carve out in a specific pattern that aren't actually isolated.
Yeah, gotcha. Chris, thank you so much. Super interesting talk. Great slides, great presentation.
Cool.
Can't wait to see you in London for Rust Nation and your presentation there.
Yeah, that'll be a lot of fun too.
Okay, Chris. See you. So it's about time. We are a little late in time. That's why I would move right on. Thierry, I hope you're ready. Let's get you on stage.
Indeed, I am. Okay.
Amazing. So where are your slides? I'm lost.
I'm gonna share my slides.
Yes, perfect.
Share screen.
So stream. Thierry is one of my personal heroes in the Bevy community because when I was just about to give up building a mobile app in Bevy, I figured that he was actually working on the biggest problem that I had, and that was upgrading one of its central dependencies. And I believe we will hear some bits about that today.
Yeah, we'll see about it. So, hello everybody, thank you for coming, and thanks Stefan for the organization. I'm Thierry Berger, I love open source, and I'm here with you today to tell you a story of a contribution or a few contributions, we'll see. So follow me, let's make things better. I don't know about you, but I have a dream. And my dream is that different players from different interests, different social circles with different resources, available time, and different, you name it, are able to play together. And let's picture a grandmother playing her favorite match 3 game. She will be able to send her hard-won candy to her grandchild, who then will be able to feed it to their cute little pet in a Crab Life simulator game. And I can hear the grandchild say, "Thanks, Grandma," and I feel their pride swelling from that interaction. So I'm so motivated in that pitch that I started a hobby project with the Bevy engine and using the Bevy EGUI library, which is a bridge to EGUI library, a UI library, you've guessed it. And a central element of that project is an email password input because I want my players to be authenticated. And the project was going smoothly until I hit a problem. I noticed I couldn't input an @ and that's a big problem because every email addresses have an @ so if players can't register, that's a problem. But first, I have to tell you a bit more about my keyboard. I'm French. I use an AZERTY keyboard. So that means to input an @ I have to type Alt then 0. And behind the scenes on Windows, it's actually equivalent to Control and Alt and 0. And that control mapping is important because control can have a lot of capabilities. It can scroll when used with mouse wheel. It can select all when used with A. It can move the cursor with the arrow keys. It can cut, copy, paste. It can even open the task manager, and I don't know, the list goes on. So I opened an issue to discuss it with Bevy EGUI maintainers. And after a long thread of discussion, we eventually, it goes on, okay. We eventually landed a fix. Wow, like one line, really? I think it's really interesting when discussions are way longer than the actual fix. It really shows that communication in software development is very important. So don't hesitate to ask if you have a problem, and eventually everything will make progress. I promise. We merged it. Yeah. So now we fixed our @ sign, right? We can just profit, plug things together, everything will work, right? Not quite yet. That password field was my next difficulty. First, I want to tell you a bit more about my project. I want to support one-time authentication, so users registers to my application. The application backend sends a one-time password to the user, and then the user goes to their email client, copies that one-time password and into my application and into that password field, right? And on web, on Windows, it's working perfectly. I can copy paste all right. It's good. But on web, web, you know. Let's rewind a bit. Bevy EGUI uses the library ARboard, which is a good clipboard crate, but it has a synchronous API. And on web, we cannot quite have blocking calls as it would freeze the entire browser. So it's just not allowed. And ARboard desires to stay simple. So that means I can't fix that on ARboard. I can't add that features. And Bevy EGUI approached that problem by implementing a local-only clipboard. It's great to have to copy a text from our application into our same application, and that's not enough for my use case because I want my text to come from another application. So, time to fix it. First, when I want to study a fix, I check what are my options, documentation of general thing, and I check also how other projects are doing it. Mainly eFrame was a big source of inspiration, which is an official framework for EGUI. And I could quickly have something working on Windows and web by using a JavaScript hook via the WebSys crate to interface with JavaScript. And so I could bypass all the Bevy machinery and get directly the event of copy, cut, and paste and stuff. So that was working fine. Yeah. Oh. Again, a problem. On Mac and web, I noticed that control was not really well implemented because on Mac, a Mac user, they don't control A for select all, they command A. But why am I talking about with you about control or command or select all? It's not related to copy paste. Well, it is because as I'm bypassing the input, my pull request was reacting to Command C and Command V to copy paste, but then Control A is going through the whole Bevy machinery. So we really don't want to support Control A for basic input text, and then Command C, Command V. It's not intuitive for users, so it's not acceptable to my standard. So I fixed that by checking for the user agent on web to correctly detect the Macintosh. So that's a lot of things. The state of my story right now is that I have a clipboard fix waiting in review for Bevy EGUI. And I understand that there is a lot of things to be tested. There's QWERTY, there's RZERTY, there is a web, there is a lot of operating systems. So I let it sit in review. Also, the maintainers of Bevy EGUI is Ukrainian, so you can guess he has a lot of other stuff to do. Anyway, I can just target my my pull request and advance on my thing. So let's plug things together. Everything will work, right? Did I tell that already? Yeah, not quite. What is going on? Okay, remember that first fix we did about that @ sign? I tested on Windows, and then at the time I wasn't tested on web. So let's explain a little bit more what it does. Basically, it says if we're hitting Control, it's not a text. It will not do a text. But if we're on Windows and using Control and using Alt, it might be a text. Yeah, I'm not so proud of this fix, but yeah, it works. So it's fine. But, yeah. But then on web, it doesn't work because that target OS is run at compilation time and it doesn't equate to Windows. It's actually WASM32 unknown something. So it's deciding no, it's not typing text. So time to fix it because I try to do things the correct way. It's a different fix, so I opened a different pull request in order to have that isolated. So at first I wasn't too sure about it at the time. Now I know more things, and I hope I explain it more clearly. But at the time, I tried just to remove that check for the platform, and I was pretty confident in it. It was working on Windows and web, so yeah, okay, cool. But then I went the extra mile, and that's a mistake. But we'll see about it. I was like, what about alt code? I'm French. I like E, I like O, I like I like weird characters, and alt plus signs, alt codes help me do that. Especially if I'm on a QWERTY keyboard, I'm able to do that. So a lot of users I know use that. So let's just get rid of that. I don't know. I was a bit confused. And then I looked a bit more in the code, and I saw there is a check like is control. What is this? Well, maybe this whole if is not necessary. So let's get just rid of that. Yeah, you guessed it at the time. I think in hindsight, I was a little bit burnt out, and that was me at the time. Yeah. So I decided I had to take a step back and just reflect, not reflection, but think about how things were working really upstream. So I looked at the Winit crate, which is a Bevy backend for handling windowing and raw inputs. And I noticed that Winit did a giant refactor of the keyboard inputs and also a lot of other little fixes here and there and there and there. So I was like, that's intimidating. If they do a big giant refactor, will I have to go through all that again? So I thought, let's update Winit. Okay, in open source, mistakes happen. I'm doing this by my spare time, so I think I wasn't too thinking clearly. But anyway, Winit update is useful anyway, so let's update Winit. I knew it wasn't going to be easy. I had to track Bevy main branch as well as Winit main branch, both getting new commits every day. So I had to have a plan. The risk was getting upstream bugs, incompatible changes, and resolving conflicts regularly. So I had to have a strong plan. First, I would update the dependencies at the minimum level, like get everything compiled first, and then everything go to work, and then I could profit. So first thing first, when doing a dependency update, is to research your subject, check the documentation, check the change logs, check the issues, the pull requests, the chat with relevant experts. I was actually updating to main, so that's why I couldn't just refer to documentation. I had to forage through the source code and stuff. A first task I did when I was confident and rolled up my sleeves to dive into the code was to update a lot of enum names, and I am very thankful that my IDE support for regex capturing in search and replace. Then another task I did was to update a lot of dependencies. As you can see, there was a bunch, and I'd like to focus on a particular one, row window handle. So that's a crate to provide a common interface for handling windowing. And as you can see, most of our dependencies updated already on their main branch or published crate to row window handle version 6, but WGPY, I won't go into detail yet, but it's a dependency which wasn't updated. And I felt adding that, I felt fixing or helping WGPU to update or tracking WGPU main would be too much of a time sink. I had already 2 main branch to track, so yeah. And that's a problem because on Bevy, we use cargo deny, which helps us prevent from using a few duplicate dependencies. And if you use cargo tree, it's very helpful to make sense of how dependencies are laid out. Anyway, that meant I had to use row window handle version 0.5. It's quite interesting how Winit or row window handle ecosystem handled that. By using cargo features, you can opt in any row window handle version you want and get your dependency tree consistent on the same version. I had to work with a few dependencies, but everyone was very reactive. So eventually, my pull request was satisfying Bevy continuous integration suite. So now we can profit, right? Not quite yet. The Winit update impacts a lot of things. So a lot of configuration, hardware, use cases have to be tested. And unfortunately, I don't have every configuration and limited time. So I reached out to Bevy Discord for help, like, hey, my pull request is nearing completion. Can you help me test it and review it, please? And thank you to all reviewers and everyone who chimed in. It was very helpful. If you want to get involved in Bevy, it's a great way to go and check the pull requests. And eventually, now the Winit was merged just recently. So yeah. So now we can profit, right? Not quite yet, again. When doing any work, I like to focus on the objective, even if that means taking shortcuts. So to merge this pull request in a decent amount of time, I had to take a few shortcuts, and I noted them all as faithfully as I could in a follow-up issue. And you can see there is a lot of stuff to be done yet. Personally, I think I will step back on a more observer role or something until things settle a bit, mostly in my brain. Yeah, so now where are we on my application, on my dream? we fixed a lot of things. We implemented cut, copy, and paste via JavaScript events. We detected map on the web via user agent to correctly support command or control depending on the underlying platform. We even updated Winit. So is it fixed yet? Not quite yet. I have limited time, so it's not there yet, but I'm confident next time we talk, I will tell you how everything works. Thank you for tuning in. Thank you for listening. I'd like to emphasize just that communication is a very central piece of in software development. So yeah, that's it. That's my conclusion.
Thanks,
Thank you.
Thierry. Thanks, Thierry. So speaking of communication, we have a bunch of questions for you. First of all, what could the Bevy team and community do to make contributions like yours less friction?
I feel like I didn't have much friction, but we need a review team. Well, that's my answer. We need a review team, and yeah.
What's going to be the role of the review team? Is it
to
that we are
make
just
sure
having too much stuff hanging in review?
It's triage.
Okay.
Triage. Alice does a wonderful job by making this public with the main merge train on Monday. That's great, and yeah, I think a lot of people, including me, are a bit intimidating by going into review. So yeah, if you want to have one conclusion, it's go review. You can do it, be it experts or newcomers. Everyone can review, and it's very helpful to the contributor, but also the reviewers and also future readers, as all can learn from that interaction.
Maybe we should encourage Chris to do more code review of PRs in his streams.
Yeah, for sure, a video of a code review.
And do you have any ideas how we in both the Rust and Bevy ecosystem can reduce or manage hardware and OS specific bugs like yours better?
That's a tough question. No.
I mean, are these things that we could at least test in a CI so that it doesn't break eventually again?
Yeah, well, Bevy, yeah, the main objective is to test on hardware directly, and Bevy does that already on a few hardware, but it's very intricate. At least in my mind, it's very intricate and very hard to test. But there is work on that, and we're working closely with Winit team to make that advance. Yeah.
Okay, and what do you believe are the weakest areas of Bevy for small games and for large games? As you discussed now, issues that you had with keyboard and clipboard, have you already seen other things?
Yeah, first of all, I think Bevy is a very strong foundation, but it lacks the commercial interest. Like the big giants, Unity, Godot starting. Well, Godot is already quite here. Bevy doesn't have the big giants providing the maturity and the experience of it, and that's what is lacking. And we can feel. I have another project on my website talking about how to integrate ads, and that's where the monetization is coming from for a lot of games. I'm working on game dev using ads our main revenue. So I think just professional and commercial and monetary solutions are not quite there yet, but it's normal. It's just very young engine. So I hope I will be working on that to bring Bevy to the next level.
Me too, for sure. Okay, last question. Such recursion of crates you had to turtle down, do we need to internalize more dependencies into Bevy itself?
I'm in no position to answer that, but
If you were.
if I were, I would be a bit reluctant to do that and prefer working with upstream as much as I can, because it encourages everyone to do it. And also, a big strength of Bevy is that it's very modular. So I talk a lot about Winit, but we can very well replace Winit by another backend. And bringing in crates directly into Bevy might be a chance of erasing all the other possibilities. So yeah, that's my answer.
Gotcha. Thierry, thank you so much for your talk and your work
Thank you.
in the community. And I'm happy to see more, especially those mentioned crates coming for monetization to professionalize their usage on mobile.
Next talk. Thank you.
Exactly.
See you.
Bye, Thierry. Dusty, next up, we are going to talk about your phenomenal mobile app based on Bevy, Numinal, which taught a stupid artist like me even to create 3D meshes. So I'm very excited to hear more about it.
Hi, my name's Dusty, and I created an app back in 2021 called Nominal. And so this is really about my experience using Bevy to make that. So to go back, when I first started really the idea of what I wanted to make, I started back in 2009 using Haskell. So this is before, I think this is long before Rust was even a thing. And so the idea was, I love Haskell. I wanted to make a 3D game, but making the game I kind of wanted to make that in 3D, just the assets, it's so much work to create just meshes and so I had some experience doing it, and I was like, there's no way I could do this on my own if I'm just using conventional tools. So I figured, whenever I hit this sort of problem as a programmer, what I do is I make the computer do it for me, because computers are fast and they're great at doing such things. So, and naturally I would use Haskell, my favorite programming language. And so I set off to do this, and starting with the 3D convex hull. 12 years later, because this is an incredibly a rabbit hole, if you know anything about 3D geometry. I worked on this, and then I kind of just dropped it because I just knew I couldn't hit the performance target that I needed to hit to make this work. So it's like, okay, I need something else. What I have just isn't going to cut it. Maybe computers will get faster. I don't know. So 12 years later, I'm like, I really want to pick this up. I think this can be something. I've used Rust a little bit, and I spent a lot of time using C. I'm like, I think I can do this. And so just evaluating the different languages available to me. One thing in particular about Rust, so in this particular odd situation, Haskell or Rust really inherits, or it seems to get a lot of its trait design from Haskell, or at least it's heavily influenced by it. So they're similar to Haskell's type classes. And at the scale that I was at, it's really important to be able to kind of copy things over trait at a time, object at a time. It just makes it really easier to do a large port. So this is not a huge code base, but I think it's about 20,000 lines at the time. And I really just wanted to port it directly into Rust, functional code, tested, works in Haskell. And so I was able to do that. It took a little while. It took 3 months, but the result was incredible. The performance was 20 times as fast. So I went from taking a quarter of a second to being able to hit interactive rates on an old 10-year-old laptop. So another thing that attracted me to Rust is the vibrant community with lots of crates, and specifically a game engine that's really got a lot of people behind it. So that leads to Bevy. Like many people, I think there was a strong temptation to just be like, this has to be written from scratch. This is something unique. Nobody has ever done this. But I have to keep my ego in check because I set a timeline for myself. I wanted to make something, an actual game, a publishable game in 2 years. And I knew that if I do everything from scratch, that's just not going to happen. I'll fall into the trap of making my own engine and never getting anything done. So I looked at the big engines. I tried to be responsible. Look at Unity because everybody's using Unity. It's not Rust or anything, but maybe I could cobble something together. I looked at Unreal, but really Bevy seemed to be a great fit for what I needed. It was able to target Apple because my target that I wanted to run on was an iPad. And it provided much of what I needed, but it really lets me take it apart so that I can make it really my own engine. I can pull out the pieces I need, hack away, and get what I want. And furthermore, the community is excellent. So they've given me a lot of support in getting it to do what I needed it to do, and as well as accepted PRs upstream to get Bevy to where it needed to be for me. As a quick overview of a quick overview of the things that I worked on in Nominal, like the particular areas. This is what the interface looks like. You can see on the right, this is from the help. We've got the big stage in the center. The bars are the shelf on the left and the stack on the bottom. The ribbon that has all the command icons that you can click on. So the stage is interesting, and it was a lot of math because what I wanted to do was basically implement VR, like a VR type of control, but using only a 2D surface. And so to do that, I needed to unproject movements into 3D space. And I found this is called direct manipulation. In particular, it's 3D direct manipulation. What we're used to on touchscreens is 2D direct manipulation. The idea being your movements are mirrored by things in the user interface. And so this took a lot of math and experimentation, but I got that working. That was kind of like the first thing to prove that this concept could work. And then I needed to implement the bars on the side. So this was interesting, particularly with Bevy, because I needed multiple cameras to be able to overlay those so that like anything in the stage would not block the bars because it's not clipped at the edge of the bars. They just kind of overlay. That was a lot of work to get multiple cameras working, and also the handoff between when you move something out of a bar and back into it. It has to smoothly let the bar kind of take over control. You can't see this, unfortunately, because it's not animated, but all the models in the bars kind of slowly rotate on their own. The commands, so those are the different icons on the bar. I started with Bevy's buttons, but I ended up replacing those with my own code. So they're basically just they're just images, and I do all the input control. Another thing, and this will be common to any sort of editor type. So I think maybe this should be something that could be abstracted, but an undo redo system. My initial idea was to sort of almost implement like a version control system where you could kind of have a chain of differences and move forward and backwards on those. But I wasted a lot of time on that. And I found that it's just easier to use full snapshots and cycle through those. So that's kind of a quick overview of the different areas in the interface. And then I wanted to use physics to implement constraints. So the idea being you could, as in real life, smash things together, like maybe put a wheel in place in a wheel well, and it would kind of clunk into place because you wouldn't be able to overlap physical shapes. I started with Rapier for that, implementing my own custom shape. But I found there was just a lot of friction with Rapier. And didn't have great performance, and that could have been partly my own fault because I had to implement collision, but it was also a lot of work to track Bevy main. So every time I wanted to make a change, I wanted to follow or update to pull in some new feature, I would end up having to fight the Bevy Rapier plugin and make a bunch of changes and essentially vendor that. And that was quite a bit of my time. So in my library in Facet, I already had collision detection. So I just needed really a solver. I really wanted half of a physics engine, not an entire one. And I asked to see if I could do that with Rapier, but at the time it's no. Rapier runs on Perry, and that is what you need to do. So I wrote my own physics library using sequential impulse, and I call that impulse drive. And this uses Bevy ECS. So this is a custom designed for my use physics engine, which has a lot of interesting ideas, but I'm not going to go over that. Another interesting feature I implemented is Z camera. So the idea is I need to give the user some sense of depth because scale and depth look about the same on a 2D screen. They're indistinguishable. So it's hard to tell if two shapes really overlap or not. So this camera gives a view from the edge of the screen, as if you had somebody kind of standing at the edge of the screen looking in, and it is automatically controlled, so it avoids anything blocking the camera to look at what you need to see. I found this feature. This is one of the features that really just kind of clicked into place. It was still a lot of work, but using things that I had written earlier, using like raycasting and asynchronous tasks, it was able to fire off a bunch of rays and figure out how to swing the camera to look at what it needed to see. Another interesting feature that needed to be added to Bevy was the ability to render to texture. So this took some work, but that got in, and I was able to use that to display this Z camera on the edge. So this is a fairly small change to Bevy, but this was quite controversial. Changing Bevy's global transform from the same representation as transform, let's see, SRT, TRS. So instead of going scale rotation and then a 3D Vec3 for scale, it uses an affine, which is basically a 3x4. It's a 3x3 rotational matrix plus a 3-dimensional offset. So I needed that because what I realized is when you can rotate shapes around and they become unaligned, like how do you align, say, a torus or something like that? How do you ensure that those are properly aligned with the local axes? Sometimes there aren't 3 natural axes to a shape that you want to scale. And so you want to scale it across some feature that is not aligned with the axis. But there's no good way to do that. So I found in this process that the current global transform was also subtly broken because if you do it scale at anywhere except the leaf nodes, the leaf transform, they compose incorrectly and give the incorrect result. And so a particular example is if you scale down X by 50%, you rotate 45 degrees around Z and do it again, there's no way to represent this in what Bevy had at the time. So that change was able to get in, and it really works well now. So I want to talk a little bit about for a large project like this, and in particular, when you don't want to be dependent on PRs going upstream to release your own product. You really need the ability to hack at Bevy, basically make whatever changes are needed to implement the features that you need on your own timeline. And so this means essentially forking Bevy. But there's good ways and bad ways to do that. So since some changes are hard to generalize and they're just never going to make it upstream, it's good to have a way to manage that. In my case, there's few commercial users of Bevy and also a few mobile users, at least at the time. There's more now. So a lot of my changes, I needed to rip out render passes because mobile GPUs are even more affected by memory bandwidth requirements. And in particular, there was one pass, the clear pass, that would simply fill an entire render target for one color, write it back out, only for it to be immediately read back in the next pass. And this showed up clearly in the debugger. So I just ripped it out. It was pretty easy using WGPU to do that. And that in particular had a huge impact on performance. And so I was like, all right, now I know my thing to do. So I went left and right, ripping out passes, ripped out like half of them. Who needs shadows for this particular camera? Rip it out. Just pulling out passes left and right. And it easily doubled the performance. And I just went with the metal debugger, looking to see where all the time was being spent. And my first reaction was, if I see something big there and I can't immediately justify it, just rip it out. And so clearly this sort of hack and slash approach would not make it upstream. But it was the numbers that I got from this did inform later changes that would help with these issues. So things I think are a bit better now for mobile, but we'll see. Every time I do a update to the latest version of Bevy, I have to do a bit of this each time. So given that forking Bevy is not optional, how do you do it? So what I do is I track a set of so I need to track a set of patches, and I really want to upstream them. So it's good to keep them based on the latest code, so I can break these off into PRs and send them upstream. So what I do is I have two branches that I work off of. One is called upstream, and one is called fix. So the names are kind of arbitrary, but fix is what I work off of. So my products are based on my Bevy fix branch. Upstream is designed to track history. Basically, it records each merge point that I base fix off of. And so what I started with was just the fix branch. And what I found is I lost history. It wasn't immediately apparent until I wanted to go back and do like a get bisect, and found that I was missing commits because they'd been garbage collected. So I actually learned this from working with another large upstream project. This particular workflow is what you do is you take the fix branch and you merge it into another into the upstream branch, and then you immediately revert it. So it records the changes, undoes the changes, and then you take upstream and update it to the next merge point. So much later, update it, basically do like it's kind of like a squash merge, but that doesn't work. And then keep on rebasing fix on top of upstream. The specifics on how to do this, the get commands. So I'll be able to share these slides somehow, so you got to be able to copy these. So specifically, upstream branch, check that out, merge in your work that you've done in fix, and then revert it, and then do a restore. And then do a commit. It says restore Bevy to this particular hash from upstream. And so this is my work stream now, and it works pretty well. I keep all my history. I have continually rebased changes that I can pick out one by one and submit them upstream. And so I kind of try to minimize the number of commits that I have on fix from upstream, but it's still around like, I think 20 or so. Maybe 30. So the organization of the project itself, how I lay the files out, is I use Git submodules for all of my first party crates and vendored crates. That vendored crates are outside third-party crates that I've had to fork. Those are typically anything I need to submit upstream PRs to. I will vendor those so that I can submit PRs from the from the submodule. And I use cargo patch to override where those come from so that they can come from a local path. And workspace dependencies work well to keep everything synchronized. It's not good enough just to use cargo patch because the version numbers need to match. If your version doesn't match what you have in the patch, then it will just go and grab them from upstream. And I've also recently found that Charm's soft serve, so this is a private Git server that works well over SSH. This works really well for things that are proprietary that I really don't want out on GitHub or any commonly hosted system. Looking forward, so what I've been working on right now, I had been working on debugging some problems with Facet, which is the geometry, the CSG library. And if you've done much with geometry, it's really hard to visualize particular bugs. So I decided I had been using Blender and trying to use other apps, but I figured it was time that I just write my own viewer for the custom for these particular problems. And so in the spirit of extreme overkill, I decided to use Facet to debug itself. So what you see on the screen rotating, that's generated using Facet. So it actually, all those shapes are unioned together into a single mesh, which could be, in theory, is a solid and should be 3D printable. So I use this to view as a little debugger, but I found the bigger purpose for this app is it's really like app number 2. And I realized a lot of things when you move on from the first app. There's a lot of things that can be generalized that aren't obvious until you actually try to use all the technology you had from a previous app in a new one. And what I'm looking to do next is port Bevy to the Apple Vision Pro, because I would really like to take Nominal into VR. That was really kind of what I wanted to do at first. And I didn't think the options were there. But now with the amount of power that this new system has, it should be feasible. So that's all I have.
Thank you so much, Dusty. Being able to use Bevy on Apple Vision Pro, that would be so amazing. Super interesting presentation, and I love your app. And we have a bunch of questions, but in the spirit of time, I would also hope to encourage you to stay around longer for a conversation afterwards. And I would focus on the one big question that is coming up. What's your experience having used Rust and Haskell? And what are you missing in Rust from Haskell? And how is it feasible for game development, comparing it to Haskell?
So Haskell still is quite a bit more abstract than Rust. So that it's somewhat visible in porting of functional code to Rust. It works pretty well. I found a pattern that works really well is abusing the heck out of iterators and iterator style patterns. So what would often be a list in Haskell becomes an iterator in Rust. I think the main weakness that I found was while traits are similar to type classes, they lack a lot of the power, and in particular for the hierarchy. So I was able to implement monoids, but then when you get into monads and anything, I think it's called higher order types, Rust just doesn't support that yet. So I've also had to abuse macros a fair amount. I feel like I could have done that better in Haskell. But honestly, I've kind of like been in Rust so long, it's starting to fade. I'm starting to yearn for Haskell, less, but it clearly still has lots of things that it can steal. I almost see Haskell as like upstream Rust. I think that a lot of things that get stolen from Haskell and people don't even know it. For instance, I noticed talk about the @ symbol in pattern matches. and that was clearly taken from from Haskell. So just Rust feels less abstract. So really, the biggest problem I had with Haskell was performance was a problem. But the biggest problem, I think, is it has the packaging is really difficult with Haskell and portability. So to the point where even just running anything written in Haskell on iOS would be extremely difficult. So I found that I was pretty much tied to running things on the PC. And furthermore, I'm not even sure how to distribute an app on the PC written in Haskell. So it's really kind of like if you're writing server software on a PC, on an x86 system, you're fine. But it's very limiting when you get outside of that. So I would not choose Haskell for a game, even though I really wanted to.
So portability, one of the big ones. Okay. Yeah, Dusty, I hope you can stick around for a little panel conversation at the end. And I would now move on to our almost last talk by Francois. Let's get him on stage. Francois, can you hear us?
Yeah, hello.
Perfect. Such a hero to be here today with the broken wrist, and such an important member of the Bevy community. So I'm really looking forward to your presentation, especially because I'm a huge person hoping for an editor, right? So let's hear it.
Yeah, I often do karate and I'm a bit clumsy, which doesn't go well together. So I'm often hurt. At the moment, it's the wrist. So my talk is about the editor, and you don't need the Bevy editor you think you need. You actually need the one you didn't know was possible. This will be about my thoughts on the Bevy editor. First, who am I? So I'm a contributor and user of Bevy since the version 0.2. And the point I wanted to call out was, if you have any ideas to improve testing the engine, come talk to me. I have ideas, I have opinions, but I always want to have more about this. And a disclaimer, these are my personal thoughts. They do not represent the direction of the Bevy project, the opinion of the other maintainers, and it won't enter into account when I will review peers or do anything for the editor. It's just the direction I hope things will go. So what can we find in an editor? Let's take a look at the Godot one. So we have a scene viewer, we have an inspector on the left, we have the scene hierarchy on the left, the inspector is on the right, and the project browser on the left too. Unity, pretty much the same, a big scene viewer, an inspector on the right, a hierarchy for the scene on the left, and a project browser on the bottom. Unreal, again, mostly the same. The scene viewer in the middle. This time the word outliner, which is a hierarchy, is on the right. The inspector is behind, is just under it. On the bottom, we have the project browser. And on the left, we have an helper to spawn empty objects. So these are the common parts: the scene visualization, the scene hierarchy, an inspector, and a project browser. The good news is, if you want to have that in Bevy, we already have it. It's called Bevy Inspector AGUI. It's mostly exactly the same. So we have the scene viewer, we have the inspector, and we have the scene hierarchy. So that's it. It's just missing a project browser. What's missing to get from the inspector to editor with a Bevy GUI inspector? For the moment, it's not possible to save the change made in the inspector. And that's because, as Bevy is code first, saving would actually mean editing the Rust files. So we first need to transition to a workflow that would work first with scene files. And we don't currently have interactivity in the scene, but that would just be adding something like Bevy mode picking and Bevy gizmos, and it would be very easy to add. And what would be needed to have a fast editor? We would need to be able to live reload a scene. And live reloading a scene is not just reloading the current scene, we also need to have the current state, the existing entities that are not part of the scene but we still want, and the resources to track the global state. And do we want to be able to auto-reload the Rust code? And even worse, do we want to be able to do Rust code generation? For example, if I want to change the file of a shader for a material, at the moment, it's implemented with a thread. So changing the file, we would need to change the implementation of a thread. If we want to be able to change thread through an editor, we would need to actually move that to a file instead of to a scene file or a material file instead of the Rust code. And all the other parts, so the project browser, it seems a small part, but it's actually quite useful. For example, if you want to change the texture used by your material with the project browser, you can just drag and drop it. It's a lot easier than typing the path to the file. The code editor, the shader editor. Again, nowadays we have very nice shader editors with graph, which is a lot easier than writing WGSL code. An animation editor, and the game view, scene view split. For the moment, we mostly spoke about the scene view. The difference with the game view is in game view, systems like gravity or input are running, while in scene view, you have free movement across the scene. But what's remaining for the Bevy editor? What should it do? Should it be able to edit Rust files? No, we won't recode something like VS Code or Vim. You continue using your preferred code editor. Edit 3D scenes? I think Blender is a perfectly fine tool for that. Edit sprite? Again, as a sprite is a very good tool for that. So what's an ECS editor? Is it an extremely common scene editor or whatever? No, it has. I think the interesting part of an ECS editor doesn't have to do anything to do with the scene. So what could be an entities editor? List and browse entities, run queries, and to be able to have statistics on what's happening in your application. For example, on the spawn and despawn of entities, are entities ID reused, and stuff like that. And it would be very interesting to be able to list system with a query that match an entity. So you have your entities, it's a mesh, and you want to list all the systems that would work on it. What would be a component editor? It would be able to display and edit the values, view archetype fragmentation and usage, and we could have statistics on add, remove, and change of those components. So would it be interesting to move it to a tag if it's just being added and removed all the time? Or does it actually need to be a component with a value, with a Boolean true, false, because it's just changed too often? And we would also be able to configure the storage of the component. What would be a system editor? With that, we could be able to view systems and dependencies and conflicts, and have statistics on duration of the system and on the system params. For example, the query used by the system, how many entities do they match? And all the rest that Bevy had that are not standard to the ECS, so commands, events, resource, states, and tasks. Stats on all of that. It would be very interesting to see how many commands we send on each frame. And we could be able to send manual commands, send manual events, modify the resources, change states, and monitor tasks to see that they are not stuck. For example, these are scenarios that I would want to be able to do in the ECS editor. I want to be able to show system time interact with audio components, queries and commands, to know how often I'm going to hear sounds if they are going to do things at the same time. I want to be able to monitor task spawning and find where build-up could happen. For example, if there is one system that spawn a pathfinding task that takes a lot of time, and then just after another system is spawning short task, maybe I should be able to order the systems differently so that the short task leave before. Find the big system blocking parallelism. So if there is one system, exclusive system that is very short, it's not an issue. But if there is one that it takes a long time, maybe I should be able to split it in several systems to help with parallelism and introduce other systems in between. I would like to be able also to reorder comments to limit archetype fragmentation. So for example, for the moment, we just issue the command Y by one. There is the project to be able to batch them, but maybe I should be able just to reorder them to improve the performance. And during the runtime, so during the game view, I would like to be able to enable and disable the system to change what is happening. And let's look at a few things that are already existing. So Bevy Mod Debug Dump is a plugin for Bevy that will print the graph of all the systems. It's currently just happening at the start, but imagine that in an editor when you can click on a system and see stat about it. What kind of stat? Let's look at the Flex Explorer, which is not in Rust. It's for another ACS, but we can see statistic about count of entities, performance of the frame, duration of system, all the details we want about any entities, and we can interact with that. And another existing ECS editor that we could look at is Unity Dots. So it's a screenshot I made from a few of the panels they have. For example, on the top left, we have the list of systems with the entity count they would match and the time they spent happening, and on which stage they are, which word they are working on, and their namespace, which is mostly like our scope. On the right, top right, we have a list of components. So we can see the name of the component, the kind they are, if they have data, if they are a tag. On the bottom left, we have the list of archetypes, the memory they use, and the memory that is used in them. And we have details like how many entities are in them and all the components. And on the system, on the bottom right inspector, we have the query it's using and an easy access to each component it's using and if it's read or write. That's something I would really like to see all together in the Bevy ECS editor. And there are great tools out there if you don't want a scene editor directly. For example, for the scene editor, as generalist, you can use Blender or LDTK. Both have very, very good integration with Bevy. If you want something more specialized, you have Trench Broom, which is a Quake 3 editor, or World Machine, which will help you create terrains, and many, many more. The one I'm listing in this slide are just one I saw used with Bevy. If you want to edit image, you have a lot of tools again, which are very good. I really recommend Easy Sprite for anything pixel-like with animations. If you want 2D animations, you have Reed and Spine. Both have integration with Bevy and are working really nice. And storytelling, just recently, a plugin was officially published for Yarn Spinner. Yarn is a format used for a visual novel and is very nice for storytelling. For sound effect, again, you have many tools. Is it something that we need to build into the Bevy editor, or do we rely on external tools? And for code editor, I'm not going to go into that fight, but yeah, there are a lot of good code editors already. And in closing thoughts, scene editor doesn't make sense for me until we have a scene first workflow. But we can already work on the UI, and it's fun, and it's very high impact for Bevy engine because it will be the first things newcomers will see. And again, these are personal thoughts, but to me, it's boring because it's just reproducing what everybody else is doing. It's the same thing as all the other game engine. And we should try instead to explore what makes Bevy unique. And there are a lot of low-hanging fruits on project creation, like templating, feature selection, and asset management, like configuration of meta files that could be already addressed and bring a lot of value to the project. And for the Bevy editor, look at the prototypes. It's something that started a few weeks ago, and don't hesitate to create your own and have fun. And yeah, I have a lot of opinions, but open source is meant to have fun. Don't burn out on it. So don't put pressure, just take care of yourself. Thank you.
Francois, thank you so much. Great talk. Super interesting, burning topic, right? So we have a bunch of questions, and again, we're pretty late on time. So I would pick maybe the top two for now, and then defer the rest for the end of the stream. Is that okay for you?
Yeah.
So question number one, I think the editor extendability of Unity is a huge strength. Is that a goal, and can it even be done in Rust?
I don't know in Rust, but in Bevy, yes, because we have plugin for everything and reflections. With the architecture of Bevy based on plugin, we can do a lot of things, and with reflection, we can do all the others.
But probably not at runtime, right? Like in Unity.
Do you want to edit the editor at runtime?
I've seen people do crazy things with that, yes.
Okay. I would have to see a valid workflow for it, but yeah, maybe.
Okay, and then we have what about to have a visualization how systems are executed in relation to each other, so seeing which systems run after the other and which are running in parallel.
Yeah, we almost have that with the Bevy mock debug dump, but currently it's just at build time. So it already exists. I would like to be able to use that in the editor and then be able to click on systems and zoom into what's happening in them.
Yeah, that would be awesome. Francois, thank you so much. I hope you stick around for the panel discussion at the end, and then I would move forward to Joona, our last speaker for today.
Thank you.
Joona, here you are. You are muted, and I need your slides or your share.
Yeah, it should now be there.
Yep, I can hear you. And there are the slides. Joona, you are a hero for me too, of course, because you created basically the only second physics engine for Bevy at this point. So I'm really excited to hear more information about your work on XPBD. So I wrote it down so I don't mess up the order of the letters. The stage is yours.
Yeah, thanks. So, hello, I'm Joona Alta. In the community, I go by Joona, and today I'll be talking a bit about the state of physics in Bevy, or specifically what options we have right now, and what we actually want from a physics engine, what's missing currently, and what we could do to perhaps someday upstream some physics library. And again, these opinions are just my own, and I'm just sharing my own experiences and thoughts. Yeah, I'm a Finnish high school student for a few more months now. I have roughly 7 years of programming experience, mainly as a hobby, and I'm currently the maintainer of the Bevy XPBD physics engine, which is probably the second most popular physics engine in the ecosystem. And I've also been contributing to Bevy for the last few months. Yeah. So as you may know, Bevy does not have official physics yet. So despite it being a core part of the majority of games, Bevy does not have an official solution for any physics or collision detection. And instead, it's left completely to third-party plugins like Bevy Rapier, Bevy XPBD, which is my engine, and then there's also Bevy Mod PhysX, which is a little less known, but it's bindings for the physics engine. And these engines can work really well as third-party crates. There's nothing in particular that requires them to be a part of Bevy for them to function. But in my opinion, Bevy still does need official physics eventually. It's just such a core part of game development, and it's just expected from a game engine to contain physics. It would also help with maintenance, so it's not just on the shoulders of one person, in my case, or a few people. And also we need the Bevy editor to have a good physics integration. And of course, this can be done by a third-party crate as well, but it might be easier if it's first-party. So I'll quickly cover, the general things that we want from a physics engine. I'll fly through this since I have quite a lot of slides. So of course, we want it to be fully featured. It should have rigid body dynamics, collision detection, joints, ray casting, shape casting, and continuous collision detection. These are like core features that I expect a physics engine to have. And then some nice to have things would be determinism and maybe some soft body and fluid simulation, but that's really difficult to do in real time. So yeah, probably not a high priority. Then we want it to be stable, of course. There should be no weird collision bugs or explosions or, anything unexpected like that. It should just work like you would expect. Like we don't want these random explosions. This is a screenshot from when I had some more contact stability issues in Bevy XBBD. And instead we want this beautiful, stable tower of cubes that doesn't fall over. Then we, this is an ECS-based game engine, so you of course expect it to be very fast. I'd say like over 10,000 dynamic bodies at 60 FPS would be a good target. And of course, tons of raycast and shapecasts as well. Ideally, we should support as many donuts as we can. Yeah. For this, we need a performant broad face. There's a lot of algorithms for that, different algorithms. We need a performant solver. Then there's the option of running on the GPU, but that has the challenge of overhead when transferring data between the CPU and GPU. And it can also be difficult to integrate with the ECS well, and in a user-friendly way. And often it just has high complexity and isn't really worth it. There's a great article on this from the BPU physics engine, BPU physics, not sure how to pronounce it. They went for a purely CPU-based, highly optimized engine. Then a core design philosophy of Bevy. A core design philosophy of Bevy is that we want it to be highly modular. So you should be able to freely, plug and play. You should be able to replace parts of the engine. And I feel like this should extend to the physics engine as well. And the ECS is really good here, since you can just schedule your systems anywhere and use plugins to organize things. One example from Bevy XBBD is that you can simply disable the entire broad face and make your own version of it. And another example, a more recent one, this isn't released yet, but you can even replace the entire collision backend and make a completely custom collider. Like if you wanted to make a collider based on assigned distance fields, then you could do that if you wanted to. And of course, Bevy also wants to be highly economic, so it should have an intuitive API that integrates well with the ECS, and it should have good documentation. So it should use just basic components and resources for the API. It should be very minimal, and it should avoid weird defaults. And I really prioritize documenting both APIs and architecture well. I feel like the physics engine shouldn't be this mysterious black box that you don't know how it works. And I feel like it's really important to document that side as well. And it also helps contributors a lot. And yeah, the missing docs clause can be, I like it. Yeah. So we also have a lot of these very popular existing engines that are very battle tested, like Box2D, Bullet, PhysX, and Jolt. And a lot of people might wonder why we're not just using them in Bevy. Well, first of all, we can just cross Havoc from this list. It's very proprietary. I think it costs like thousands of dollars to even get access to it. So obviously not valid here. And then Bevy has this design philosophy that it should be turtles all the way down. There's this saying that it should be pure Rust, do not have any translation layers or heavy translation layers. Ideally, engine code is game code. And it's really powerful since this makes code to definition work. So you can just, click on a component or a system or a function, and you can just go look at the source code and see how it actually works and what it does. And since it's basically like game code, you're familiar with it and can understand how it works. And yeah, this makes source code easier to inspect and contributions easier. So if we consider Rust to be a requirement, we're only really left with, one engine, which is Rapier currently from these engines. And then it also, in the case of Bevy, must work well with the ECS, and we'll get into this a bit more. So right now we have the options. We can either make a wrapper around a physics engine to integrate it with the ECS, or we can make a custom engine using the ECS. So we have both options. The first one is Bevy Rapier, which is made by Dimforge, and it's a wrapper over the Rapier physics engine, which is made in Rust. It's fully featured. It has rigid body dynamics, joints, spatial queries, character controller, and a lot more. It has an ECS-based public API. So it just uses components and resources for the most part. And the implementation is that it uses a two-phase velocity solver, if you're interested. Some pros are that it's performant, fully featured, it's relatively mature, quite ergonomic, and it does have quite good documentation, although it is a bit outdated, at least the website, and the docs and docs RS aren't as good. Yeah. Some cons are that it's just a wrapper, and this requires a translation layer between the ECS and the core physics engine. And this layer also makes the source code harder to inspect, since there's this extra glue code, you could say. Then it also uses Parry, which uses an algebra math library, while Bevy itself uses GLAM. So ideally, we don't want duplicate math dependencies. And the Bevy version of this only supports F32 precision, even though Rapier itself has F64 support. So it looks like this. You probably know already, but you add a physics plugin. You have to add these weird generics, I think. And then you add a rigid body. You have to add a velocity component to it for it to be queryable. And then you can have this movement system that updates the linear velocity. So let's take a quick look at the architecture of Rapier itself, not Bevy Rapier, but Rapier. So you don't have to worry too much about the folder structure here. It's just to show what there is. At the core, there is a physics pipeline, which is what executes the physics simulation. So it's this, you give it basically everything. You give it the broad phase, narrow phase. You give it all the bodies you want to simulate, all the colliders, joints. You give it everything essentially. And you might see this rigid body set and collider set. These are just basically containers that contain all the rigid bodies in these data structures called arenas. And each rigid body is this huge struct which has all the components in one place like this. So you can see that the design is quite monolithic, basically. Like you give this one function basically all of your state, and then your rigid bodies have all of their state in one place. And yeah. And then the way Bevy API actually interfaces with this is that, well, for the physics plugin, it has these systems that you can see there's a lot of initialization systems, and these systems that apply user changes, and then some write back systems. So one example of an user change applying system is this. So it basically has queries for like basically every component, and it checks if it basically checks all physics components, and if they changed, it gets the corresponding rigid body on the API side and updates the value. And then at the end of the frame, it writes the changes API made back to the ECS. So yeah, and then there's also this huge API context resource which contains the entire state of the simulation, like the narrow phase and broad phase and so on. So you can see that it's really is quite monolithic. It syncs all the data like this, and it contains the simulation data in these huge structs, which isn't inherently bad, but it's not how Bevy works and the ECS. So now we have Bevy XPBD, which is my engine, inspired by a tutorial series by Joona. It's built for Bevy with its ECS and has a highly modular plugin architecture. It has tons of features, again, including F6 force ports. And it uses extended position-based dynamics, which is where the name comes from. Some pros are that it's built with the ECS purely, so it's just component systems and resources organized via plugins. And this makes it very modular and extendable and quite ergonomic, since it's just like the rest of Bevy. And I'd say it's also well documented, although it doesn't have a separate website. The docs are just on docs.rs. And in theory, XPBD should be a very stable simulation method. But there can be bugs, of course, that affect it. So some cons, it's still very young. 0.1 was released just over half a year ago, whereas Rapia has existed for years, and its predecessor NPhysics is even older. It's still missing some important features like joint motors and CCD, and it's not properly optimized yet, and it also uses parry like Rapia does. Here's the same example. It's mostly the same, except the plugin name is a bit different. It's actually a plugin group. You don't have to manually add velocity component, and linear velocity and angular velocity are split into separate components. Yeah. So Bevy XPBD's architecture is quite a lot simpler. Here you can see the folder structure. There's just, it's just plugins. There's a broad phase plugin, narrow phase plugin, integrator plugin, solver plugin, and so on. Everything is in these plugins. And the physics logic just uses raw systems like this. It's just normal systems. It queries for colliders and updates resources and whatnot. Here's another example. This solves constraints. It iterates through constraints, and then it solves them by querying for the rigid bodies. And another benefit to this is that you can just, it just uses these system sets, and you can schedule your own systems relative to this. So in Rapia, you would have to use these hooks, and they only hook in the specific parts of the engine, so you can't really freely change things around. And here you can see some of the components. So it's basically just components. So we have these two good physics engines. So what's missing for official physics? Why haven't we adopted them? Well, again, Bevy Rapia isn't built with the ECS. Bevy XPBD is incomplete, and they both use parry and therefore algebra. And we really don't want duplicate math grades because it's just rather confusing and adds some complexity, and also adds to compile times and binary size and so on. So ideally, we want GLAM-based collision detection. Then there's the question of which solver to use, a position-based or velocity-based approach, whether we want a separate physics world versus the ECS-based physics world. Both do have pros and cons. You can maybe do some specific optimizations if it's separate. Then we have the issue of how to handle the 2D, 3D splits. Currently, we have separate grades for this, like Bevy XBBD 2D and Bevy XBBD 3D. But we could also have a unified Bevy physics that has separate components like rigid body 2D and rigid body 3D. So we need more experimentation to find the best approaches. And I'll quickly go through some experiments that I've personally been doing and will continue to do. So first off, we have the GLAM-based collision detection. The goal is to use just Bevy math and the new geometric primitives, which are upcoming in 0.13. Look forward to those. It should support, the basic collision detection features like generating contact manifolds, raycasting, shapecasting, and creating complex collider shapes. And optionally, it could have also a plugin and component for Bevy. So option 1 is to, replace Parry with what I call Barry, which is a fork of Parry using Bevy math. So in theory, this would give us fully featured collision detection with Bevy's own types without reinventing the wheel. But this is still a lot of work since Parry is really big and there's some things need to be re-implemented also. And yeah. And there's also the challenge of keeping it in sync with upstream Parry since the entire math library is different. So yeah, that might be a bit painful. My current progress is that I have managed to switch the math library, but I haven't yet switched to Bevy's geometric primitives for the shapes, although I am trying to do that. The second option, which I'm also trying, is a collision detection library from scratch, which I call Bevy Peck. There's a beautiful logo for it. So everything is made with Bevy's types. We have full freedom to experiment. And even if this doesn't become anything like good, it's still fun and a great learning experience for me personally. But it is a massive undertaking to, make Parry from scratch, basically, with, fully custom made. My current progress is that I have basic JGK implementation mostly working, and the expanding polytope algorithm mostly working as well. And if we implement these properly, then we have basically all we need for contact generation and basic collision detection. Yeah, then alternative solvers quickly. There's a lot of options: position-based, impulse-based, velocity-based, or a hybrid. Recently, Bevy Rapia actually implemented a small step solver, which is kind of like what XBBD does with substepping, which improved the convergence a lot. And I feel like we should really experiment more and compare the different solvers. And ideally, the solver is just a plugin that can be swapped. So, like in Bevy XBBD, you could just switch the XBBD to sequential impulses, for example, which I have tried doing already. And that screenshot is actually using sequential impulses in Bevy XBBD. It has limited functionality and some instability, but in theory, the idea of a swappable solver seemed relatively viable. And then quickly, 2D and 3D in one crate. My idea is that there be separate components, kind of like in Godot, or Godot's nodes, but some components could still be one component, like friction, since it's not dimension specific. And then we can use traits and generic plugins to reuse code a lot. So to summarize, Bevy will get an official physics engine eventually. The engine should be built in Rust and integrate well with the ECS. whatever that means. It can be done in different ways. But there is still work to be done and several open questions, like we need, or at least heavily want, GLAM-based collision detection. We need to figure out the 2D-3D split and which solver to use. And then there's the question of separate physics world versus easier-based physics world. And yeah, I hope that we can find some answers to this in this year, and I will try my best to address some of these issues. I think physics simulations are super interesting and rewarding. So I also would encourage others to try making their own engine. It's, Bevy XBBD started just as a, fun side project, and eventually it became what it is today. So, I encourage everyone to experiment with different things, since it's really interesting and fun. Yeah, thanks.
Thank you so much, Joona. That's so impressive. How did you finish high school while doing this? That's amazing. There's a bunch of questions. I would say let's start with 2 or 3 like from the top, and then open the panel discussion for everyone so that it's then fair. So the highest voted question is actually, what is necessary to make it fully deterministic?
I'm not sure. Well, of course, we need to make sure that it's not query order dependent. Bevy doesn't give guarantees that entity query order is deterministic always. So we need to make sure that it's not dependent on that. And if it is, then we need to maybe sort some query results in some way. And just in general, make sure that things aren't order dependent. And this is a challenge if we do multi-threading, because there we can have a lot of parallel things happening, and it's not guaranteed in which order those are happening. So yeah, it could move one body. Yeah.
So it's not just an XPBD question, but also a very wide one. Okay.
Yeah, and also floating point determinism.
Yeah, well, that
is required for cross-platform determinism. Yeah.
How do you make sure this important project scales post high school? Do you onboard co-maintainers?
Yeah, I don't know. Yeah. So I have my matriculation exams in like a bit over a month, so I'll be quite inactive for a while. But after April or after March, I think I'll be free for like 5 or 6 months straight, I think, since I won't have any school or anything. So for that period, I'll be working quite heavily on Bevy XPBD and other related things. But in university, I'm not sure. I guess time will tell.
But are you open for co-contributors, making them be able to contribute like a maintainer at some point?
Yeah, I'd be open to maintenance. I'm not sure right now who that would be, but yeah, I'm already, people have made a lot of PRs already and stuff, but yeah, I don't know who a co-maintainer would be right now, but yeah, I'd be open to it.
Cool. So if there's anyone in the stream, earn your reputation, and then there might be a chance.
Yeah.
Okay, cool. Last specific question to you would be, would it be possible to add more documentation about testing with XPBD? At the moment, it's not obvious how to run physics updates inside a Bevy test. That's very specific.
I feel like this is referencing an issue in repo. Actually, I saw one, but I didn't respond yet. But there's a few tests in the repo that show how to run tests. I'm not sure if it was something specific like running in fixed updates. I think there you might need to run some schedules manually or something. I don't remember
so
exactly.
Probably best to refer to the issue then and have that conversation.
Yeah,
there.
if it's related, then yeah.
Yeah. And then tight ECS integration means also there's no public-private API separation. Is that correct? And how do you keep the user then from shooting themselves in the foot?
Well, there's a few ways. Of course, we can keep systems private where they, we don't need to make systems all systems public, and then we can use system sets to give users places to add their systems in the schedule. So I could add let's say some physics sets first, system sets, for example, that wouldn't have any systems, and then the user could add systems there so that they can run things before physics, for example. And we can extend that to other parts of the engine. One example is that we have a post-process collision schedule, which basically is just an empty schedule meant purely for adding your own system so that you can do some post-processing on collision data and stuff. So basically just system sets and schedules and document how they should be used.
But we cannot really keep people from manipulating components, right?
No, but yeah, we can't really stop that. But yeah, I'm not sure what the answer there is. It's good to have that flexibility, but I guess it can open the door to some foot guns as well. Yeah.
Okay, Joona, thank you so much. I'm going to pull in everyone else now, and then we're going to go through questions that are still open for everyone. Feel free to hang around, and super big thanks to your presentation. This is an immensely huge project for a single person, so I'm super thankful that you're taking this on.
Thanks.
So let's get everyone up here. Chris, Thierry, Dusty, I think I have everyone. Thank you guys so much for your presentations. Such a great quality and so many interesting topics. So are you willing to take more questions then?
Sure.
Let me put them up here again because I hit them, most of them now. But the first one is already pretty obvious for Alice. Is there a common way to add more reflectable metadata like min-max values for editors?
Yeah, so I actually cheated a little bit, and Mr. GVSV was chatting with him during the other talks, and he says that this should actually be quite feasible to implement by just shoving it into the type data, which makes sense to me. I've seen that the Bevy Inspector GUI does something very similar with its own trait. I'm definitely, as we move closer towards a actual first-party inspector editor quasi thing, to making sure that works first-party without needing an additional trait.
Okay, that's pretty cool. And the next one goes to Dusty. When implementing an undo-redo system in Bevy, what should we be mindful of, given that you have some experience with that?
It really comes down to, at least the way I did it, serialization. You need to be able to serialize and kind of bring things back and out quickly. So I guess that's it. It really comes into being able to serialize everything, the state, and bringing it and do that. There was also an interesting article I saw online. I don't think I've quite implemented this in Nominal yet, but so there's a way to linearize undo and redo. The idea is that you have a redo stack, and that keeps, every time you undo, it pushes it onto the redo stack. But when you want to make a change, so say you have something in that stack The way I currently do it is I just basically drop that redo stack and you lose that work. But there's a way to keep that work. What you do is you essentially take that, replay it, and this is kind of more of a Git way of thinking, but at least with states it's pretty easy. You just keep you push the redo stack back on, and then you jump to the previous state and make changes from there. So that way you don't lose anything that you've done. So this kind of like linearizes. It's essentially like doing a revert in Git. It'd be like doing a revert commit before you make any changes. So I guess that's something to consider. So otherwise it can be disconcerting for the user that they've done a bunch of work and they go back and then they make like a small tiny change that's almost inconceivable, like maybe change a color or something, and then bam, all that they can't redo anymore because they can't replay the changes they made on top of that. So it's a surprisingly complex subject, I guess.
Yeah. What made you go to this to use this snapshot-based approach versus the diffs, I guess?
It turned out that the amount of state I needed to hold on to was relatively small, and getting a change-based system to work correctly, like especially if you scrub forward and backwards, it just makes it's a lot more chance for errors to propagate. And I kind of had some experience working on like a MIDI recorder also that did something similar, and I switched to a state-based system just because jumping around is easier when you don't have to step through all the steps in between.
Okay.
So
thanks, Dusty. The next one goes to Francois. Could you give us an example of things that you that could add value to the project in your opinion? I guess that is assuming someone has some time at their hand and they want to contribute to the editor effort.
Yeah, sure. An easy example would be asset processing. It was added in Bevy 0.12, but at the moment, if you want to do asset processing, you have to add them to your project, then run through your whole game to make sure all the assets are loaded, then save the asset processing, modify your game to disable it, and use directly the processed asset. We would need something to be able to process the asset outside of the game. And something too for the meta files management. At the moment, we don't have a way to create them easily, so it's manually edited. We could really use something for asset management.
Okay, interesting. Is there like a ticket open for that, or an issue, or RFC, something like that people can jump on?
Probably a few lines in a PR by cart.
Okay. Cool. Joona, about XPBD, are you or do you plan to get in touch with Foresight Corporation regarding Barry? Foresight is a strong actor in the Bevy ecosystem, and from my understanding, they are also related to Rapier.
Yeah, I don't plan on, contacting them necessarily. I'm not sure. I don't think I need to really. I'm not sure what I would, I guess, help, migrating it to Bevy, but it's not, it's mostly just like manual work. Like there's not that much complexity to just switching the math types and stuff. It's mostly just someone has to do it, basically. But yeah.
Yeah. Okay. And Dusty, this is another Haskell question. Because of how surprised you were, do you think that Haskell community is not honest about Haskell's performance?
No, I don't think so. This isn't a problem with Haskell in particular. It's that Haskell makes it hard to really reason about memory behavior. And this is like a known problem, I guess, with really functional languages in general. But contrasting it with C, I can tell you exactly which bits are going to go where. And because garbage collected languages in general tend to scatter memory across across the heap, then it's really hard to optimize for memory. So I would say it's not Haskell specific, but it's garbage collection. And it's not the problem you think it is. It's not the garbage collection operation, but it's the problem that you can't organize how your memory is going to be written and read. And that has become increasingly important because of disparity between memory performance and CPU performance. You really need to have an idea of what access patterns you need and be able to lay them out properly. So this is, garbage collected languages in general. So ruling those out, you're stuck with, of course, Rust, C, C++, anything that you have direct control over memory. And out of those, Rust is the one that can do so safely.
Yeah, gotcha. I actually didn't even know that Haskell is GC'd, but yeah, today I learned. Cool. Joona, another one about inverse kinematics. Could you talk about that? What is needed to add this to Bevy?
Yeah, I'm not really familiar with inverse kinematics. I feel like it's more of an animation thing, kind of. Or not necessarily. I don't know.
Okay.
I'm not very familiar with it, so I wouldn't know, unfortunately.
So this calls for contributors, I guess. Cool. Alice, is Bevy Reflect basically complete, or are there more features that we are looking to add to it?
So I'm not a reflection SME. I merely maintain it. I merely help out with reviews mostly, and occasional fixes. But Bevy Reflect is basically functional, basically usable. There's a lot of like rearranging deck chairs, making things nicer, making things prettier. The only big the major structural change that I would like to see is recursive type registration, where you go and when you register a type, it then registers every other type that's in there and has been seen, just to reduce boilerplate. And the other thing that I would like to see is the remote reflect work being done, where you use questionably cursed things to kind of implement reflect on foreign types, which was a technique stolen by Serde, and it's very tricky to get the details right, so we haven't landed that. But both of those are examples of like meaningful things we can add to Bevy Reflect, but it's certainly a lot more mature than something like Bevy ECS, where we have 50 large outstanding features where it's like, yeah, sure, I would like this feature.
Okay. So we are closing in on the last few questions here. Will reflection ever be mature enough so that we can deep clone entity components, or is that more of a storage principle? I guess that goes to your deep reflection topic.
Yeah, so talking this over with Mr. GVSC again, who's been fantastic. Basically, we already have the ability to clone arbitrary data types using the reflect clone value, which will then go and recursively actually instantiate new things. It's kind of cursed because it doesn't actually require a clone bound; it just reflect bound, so you can actually clone objects. You clone objects and deep clone objects in this way without needing the clone trait per se. So it already exists.
Okay, that's cool. Chris, this one's for you. Would a Bevy crate registry just around experiments and plugins make sense?
I think we already have plenty of ways to get Bevy plugins in. I think anything on GitHub you can pull in via cargo, which is absolutely wonderful. So I don't know that we need a special registry of any kind. We have experimental on GitHub, and we have published on crates.io, and I'm not sure we need more than that.
Makes sense. Okay. Dusty, you talked about render to texture in your presentation. Was that a feature that you contributed to Bevy? And if so, how hard was that? And how long did it take?
Yeah, sort of. I kind of revived it. So there had been rendered to texture before that in one of the examples, and it was ripped out as part of rendering upgrades to the rendering system. So I worked on adding that back in. It was quite a while ago, so I don't know exactly how long, but my answer is generally to get anything upstream. For me, it typically took about a month. So I just kind of land on about a month for any PR, which is, I don't know, disappointing, kind of slow. Hopefully things have gotten better. I know Alice has been working hard on getting things merged quickly, and I really appreciate that. So I'd like to try upstreaming a PR again. Hopefully it'd be a quicker process, but I understand, like, I've worked with open source a lot. This is how things go, both because of the amount of things going upstream, and I could be doing better with reviewing PRs to help with that. But just like the amount of discussion that really needs to happen. So I would say, yeah, if you ever are going to submit a PR, it kind of has to be a back burner task. I get the code working on my end, and that's where my fork really helps out, because generally things don't make it in for about a month to 3 months. But in particular, the render to, I think that was one of the first more rendering heavy things I did. And Bevy is great about, you can just kind of dive into the code without any clue what the heck you're doing and just start hacking away, and things generally work out. I mean, like without having a lot of documentation, I was able to kind of understand what's going on and make the changes I wanted. So it's a great code base to hack at.
That's a great testament. That's cool to hear.
So, so kind of expanding on that answer from a maintainer's perspective, I would definitely like to get our PR latency down, especially in our backlog, and especially for more complex stuff. We're actually doing pretty well on really easy PRs, but a lot less well on tricky, complex feature PRs. But unlike in like traditional software engineering, there's two different types of time to consider when you're thinking about, okay, how long does it take to do a feature or to get something upstreamed? There's how many hours are you working on this, which is, maybe like 5 or 10 for a complex feature, and then there's how many months, like how many days, how many weeks, how many months of latency is there in between there. And those are both really important measures to bear in mind when you're trying to plan a project. But they're very different things, and it's really easy to conflate the two.
Yes.
Cool. Makes sense. Okay. Francois, will we be able to play the game, or a game, I guess, written in Bevy, right out of the editor and mess with the state of all properties at some point, just like in Unity?
That's one of the goals, yeah. How exactly, we don't know yet, because it depends if it will be the same process or different process, or it will communicate between them. But yeah, it's one of the goals.
Nice. That's so amazing once that's there. Joona, is XPBD more suitable when doing rollback networking than Rapia or Rapia?
Maybe.
Gets probably back to determinism again.
Yeah, kind of. Neither Bevy XBBD or Bevy Rapia is entirely deterministic, at least cross-platform. But so if you want perfectly deterministic rollback networking, then probably neither will be, perfect for it. But with XBBD, you can definitely do a lot more things, like custom and configure things a lot. Like you can run the schedule basically however you want. And I have seen some people make some custom schedule runners to do things like, roll back some state and then run X amount of steps to get back to the current state or whatever. So you can do quite a lot of configuration with the XBBD that you might not be able to do to the same extent in Bevy API, but yeah.
Okay. Cool. Francois, right now the eGUI inspector shows a lot of stuff that is not really useful and modifiable. Will we do better, and how will it be filtered, I guess?
It wasn't really a big issue for me, but yeah, we can do better. Will we do it it depends if someone wants to work on it. How to do it? It's back to Alice and Bevy Reflect. We will be able to add metadata to reflection, for example, to mark a field. This is interesting for the editor. And by
Cool.
default, if there
So
are no fields marked, just show everything.
contributors. Yeah. Okay, so it's doable. You heard how it's doable. Come and join and contribute. Joona, such impressive work to build this out of high school. Is Rust your first language? Was it hard to ramp up?
So I actually started as a web developer by making this, very bad website with the help of my brother, and I made like some snake game with JavaScript. Basically, I didn't code almost anything. My brother did most of the work, but yeah, I started as a web developer and learned a lot of frameworks and some backend stuff. And I think I started learning Rust just like a few years ago, like maybe 3 or 4 years ago, probably. But yeah, it was different, but I really liked learning it. It felt like coming from JavaScript, it felt like cooler kind of like it's a lot lower level compared to something like JavaScript, of course. And I did use like a bit of Kotlin and Python as well, but using Rust was like I really enjoyed learning it, even though it was a little difficult, I guess. But yeah, and I'm still learning, of course. There are things that I haven't even used in Rust. Like I haven't done much like lower level memory management stuff since like in Bevy I don't need to do that really. So yeah.
That's so cool. Last question to Dusty. Did you try Bevy XBBD? Would SDF physics have helped you with the complex shapes?
It didn't exist then. This was back in 2021 when I started. I would have been, especially where it is now, I'm really interested in the ability to decouple collisions from the solver, which is exactly what I was looking for in Rapier back then. So I don't know. At this point, though, I kind of have my own engine, and I'd kind of like to play with that just because it's fun, but which I'm sure you can understand. So I do have some different ideas with the way I do physics versus the way that they're commonly done. In particular, one that I'm particularly proud of is that I can do collisions at different rates and separate things. I can basically collide just a specific set of shapes, and then that feeds into the solver, and that's really useful to cut down on the number of things that cut down on the number of things that are checked for collision. So yeah, I guess I have something really customized to me at this point, and it would be interesting to kind of generalize that. But at the point I'm at, it really depends a lot on Facet. So unfortunately, and I'm also watching the Bevy Shapes PRs, I guess, to see if I could integrate those into my engine just for the heck of it. But one thing that makes collision a lot easier for me is that I only handle one type of shape, and that's a set of convex polyhedra. So it kind of, I don't have to have the n squared problem of having to handle all different types of collisions between different types of shapes. So it keeps it pretty small.
Yeah, but would, like, from your understanding of SDF, because that wasn't the question, would it be? Yeah, go ahead.
Yeah, SDFs. So I'm also watching that. It's interesting. SDFs, though, I think they would have strictly higher overhead than what I have. So really, if you could view Facet as a particular type of SDF. But if SDF, as I understand, is typically practiced, you kind of have to hunt around in some either regular or irregular space looking for, it's sort of an implicit surface representation. And so since I can use GJK much more quickly, I don't think SDFs would really help. I think it would have worse performance. But I am interested because it's Media Molecule. What they've done with Dreams is pretty impressive. But I actually ended up buying that game just so I could evaluate their technology. It is visible at the edges that it doesn't have clean edges. How important that is for a game is another matter. So yeah, I'm interested in SDFs. I don't think that I would switch to such a thing anywhere in the near future. Another thing that's interesting. So like I said, I'm looking at the Apple Vision Pro. The Vision, the way Apple has some privacy concerns because they use gaze tracking. So what they do is it'll track your gaze, and then it needs to have a way to highlight a particular mesh. And so you have to use Apple's render called Reality Kit to do that. And so essentially you need to be able to feed that with colliders and meshes, really cutting out a lot of these special rendering techniques because you have to use their render. And even Unity has had to bolt their engine onto Apple's render. So it kind of validates that meshes are not. Many people claim that meshes are kind of in the past and we're going to do all ray tracing in the future. But I've gotten a lot of mileage out of proper meshes with proper triangles that I can easily do collision detection on in the normal way. So it'll make it a lot easier to port to such more restricted systems that have that still use traditional rendering. So yeah, I'm kind of leery of any special rendering where SDF is also often used for rendering, but also for collision. I'm not sure. One concept in Facet is to keep things to really focus on convexity because basically all linear and log linear algorithms rely on that. And so SDFs, my understanding is they allow concave shapes, and it doesn't really. There's no magic there. Once you go to concave, you're stuck in n squared land. So things will fall apart.
Okay, Dusty, that's a lot about SDFs. Super happy to hear that you're going to port Bevy to Apple Vision Pro. That would be amazing. I can't wait for that. And thanks for your insights. So everyone, thank you so much for your presentations. This was an amazing event. I think I have to watch all these videos again and make sure that I can also publish them for everyone else to do the same. Is there any last words that you want to share before we go offline?
I really appreciate this meetup. Thanks. It's been great.
Yeah, thanks.
Thanks, Dusty.
Thank you.
Thanks.
Cool, guys. I think that was quite a ride, almost 3 hours. Maybe a little less talks next time, but this is definitely not going to be the last one of these. Thank you guys so much, and see you next time.